Hello and welcome to this presentation on the Medmont Meridia corneal topographer. In this presentation we'll be looking at scleral lens fitting. So most, if not all, corneal topographers will have a contact lens module that will allow you to do fluorescein simulations of a lens on that cornea. But unlike most topographers, the Medmont also has the capability to do scleral lens fitting with the ICD 16.5. So let's have a look at a video of an example. So here we're going to click on one of the composite maps taken for this patient, and that's important because we have this limbus to limbus coverage. Once we've done that, we can click on home and we can click on contact lens, and that opens the contact lens module. Now here in this drop down menu we've already selected the ICD 16.5, but there are other alternatives. We click on OK and that brings up this view that we have here. So here we have the specifications of a suggested trial lens, and we have a fluorescein pattern of that lens. But you can see that with standard fluorescein we're getting excessive clearance the whole way across. We could use extended fluorescein, and on the left hand side that's expanded the range of microns that covers, but that's still not as helpful as looking at this ICD clearance demonstration. So I'm just going to pause that here. What you can see here is that it's colour coded the clearance in microns with these different colours. So it's now become the equivalent of a grading scale. It shows us that over the cornea, so it shows us where we have high clearance, moderate clearance, and actually getting down towards touch and touch. You can see that across the meridian indicated by the white line in the bottom of the screen. So here it is showing the colour map and showing how it differs here. Now what it also shows is those grading scales, and it will point out in a moment that the blue area is the cornea, so anything beyond that is landing on the sclera, and that the grey area is the pupil, in this case really quite a small pupil. So what we can do here up in the top right is apply a settling depth. So we've applied 80 microns, which would be fairly average, and that changes that colour map so as to show us that it's dropped that lens down and is now in around 200 to 300 in the centre. If we wanted to increase the limbal clearance, we could increase the limbal clearance, and you'll see over on the right that we're about to apply that in that lens specification box. So it's showing us where it's going to apply it, and we add in 5 degrees and that lifts that lens up. So it lifts it up and it increases the clearance both across the limbus but also centrally as well, because it's lifted that up. So you can see from the colour coded areas how that has influenced the fit. Now we might feel that that 300 to 400 microns is too much centrally, so we can apply again in the specifications box a -5 change to the PCCZ. So this is the peripheral corneal clearance zone. That compensates centrally for the limbal clearance zone change, and you can see that it's dropped it back again down to around that 200 to 300 micron level that we would find more desirable. All we're going to do in this video now is just change those back to the standard values and apply and go back to that standard lens fit. So you can see that there's a great deal of flexibility in there to change the parameters. You can select a different trial lens and see what that would look like on that patient's eye. You can make the changes that you would be making empirically in your order and see what effect they have on that cornea. This certainly doesn't replace putting a trial lens on eye, but it really does help you understand the consequences of the fitting changes that you make better choices for your first lens and better choices when you go to place your order. Thank you very much.